Hey guys, welcome back to AlgoYogi. We are doing linked list series, and our next problem in the list is remove duplicate from sorted list. All right, let's visit the problem on LeetCode. Just one-liner or two-liner description. Given the head of a sorted linked list, delete all the duplicates nodes. I was expecting duplicate nodes such that each element appears only once. Return the linked list in sorted order as well. So we have already solved a problem where we were removing a given value. Now it's just we need to remove the duplicate values. So that's the only difference, and we have done that problem. You guys can check out the solution. The link would be somewhere in the description, or you can just please follow the channel. I would really appreciate if you subscribe or go back and watch the other videos. Pretty good. I mean, good to follow with me and solve the problems. Anyway, let's see how we're going to do it. So as you can see over here, this particular linked list contains one twice, so one of them we need to get rid of so that the next list has unique values, right? Unique integer values. So now, just like last time, we're going to have two pointers. One is, let's say, current pointer, and another one, this time previous would also point to the head also, because this time we can have at least one node of each value, because this time we don't need to remove, like let's say in the previous questions when we had to remove something, it's like if one was that value we had to remove the head as well, but this time that's not the case, because at least one of the ones can be kept and the rest of those could be removed. So now we'll keep moving current, and whenever my current is equal to my head, then I could just get rid of this, move my current pointer to the next, and point my previous next to current. All right, that's it. Honestly, the code would be super simple. That's like the real weird part about linked list problems that I'm experiencing. I just don't really know. It's just all happening in head. I don't really know how to explain it, like, because everything that I'm doing over here is translating to code right away. Do you know what I mean? Honestly, like, I'm really sorry. I think this might be a difficult situation for me because I'm not really able to explain it really well on iPad, but it's just because as I'm thinking and explaining, it's just turning into code right away. I don't know. I guess like when you'll be doing these problems, you might see that happening to you as well. So it's like I have previous and I have current pointer. That's what I was talking about just now, and they're both pointing to head. So they're both pointing to head and head. That's how it happens in Python. So now, while my current pointer is not none, if there is a case where my current dot value is equals to prev dot value, and this time because my previous is also pointing to head, in the first case, if they will basically be equal, because if every value will be equal to itself, I could honestly point it to the next, but it doesn't really matter. Current could go to the next, but however it will move itself up. You'll see why. So here my current will be current dot next, and my prev will be current. Basically my previous will point to the current as previous dot next. Sorry, because if they were equal, then prev dot next would become my current. All right, otherwise they will just move one pointer ahead. So prev will be prev dot next, and current would be You know what, let's do them in order. Current would be current dot next, and I'm just simply doing what I did in the previous problem, removing some value. It's just I had to start previous from a dummy node, because head could be the value that could have been removed. In this case, no, because we want to keep at least one value. So finally we can just return head this time. All right, in this case I think it looks correct. Let me zoom out and run it on examples. Runs pretty good. Submit it. If it is 100%, that means this is pretty efficient solution. All right, then time complexity is big of n. That's the number of nodes. It could be m. I don't know why I'm writing n. And space complexity is, we're not storing anything, so big of 1. It's basically constant. All right, let's mark our problem solved on AlgoYogi and see you guys in the next problem. Until then, bye bye.